Hello everyone, welcome back to my channel. In today's video, we are going to learn about one of the most important concepts in digital electronics, that is complement of numbers. Complements are widely used in computers and digital systems, especially for performing arithmetic operations which are like subtraction and for error detection in digital circuits. So let's get started with that. Let us first understand what is complement. In simple terms, a complement is the method of representing negative numbers or performing subtraction by addition in digital systems. Instead of doing subtraction directly, we make use of the complements to simplify the hardware design. In complement system also, there are some types. Majorly, we are going to see only two types here. One is radix complement, another one is diminished radix complement. Yes, here we have two types of the complements. First one is radix complement and second one is diminished radix complement. This radix complement is also called as R's complement and this diminished radix complement is called as R minus 1 complement. Already we know about the different types of the number systems like binary, octal, hexadecimal, decimal. In all those number system, we are going to adopt these two types of the complement systems. Let's go one by one. Okay, now let's move with the complements in the binary system. We know the basic types in the complements. One is R's complement and another one is R minus 1 whole complement. What's the base value for the binary? That is 2, right? We are going to get 2's complement and 1's complement. This come under R's complement and 1's complement will come under R minus 1 complement because here the R value means the base value of the binary will be 2. 2 minus 1 whole complement. You are going to get 1 complement here. Now let's take some example for this and perform some calculations. Let us take an example like here we are going to see the two types of numbers. One is positive number and another one is negative number. Let us go with the positive number itself. If it is positive number, we are not going with the 2's complement. We directly move with the 1's complement. How we can able to represent this in 1's complement? Simply we need to represent this 5 in the binary system. Like we already know 2 power 0, 2 power 1, 2 power 2 and 2 power 3. Let's take a 4-bit system here. Okay. So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. Okay. So where we going to get this 5? We are going to get when adding 4 and 1, right? Here and here. The remaining will be 0. Right? 0, 1, 0, 1. Then 1's complement of 5 is look like 1, 0, 1, 0. We just need to change the values of zeros and ones. If it is 0, we need to convert it to 1. If it is 1, we need to convert it to 0. Like that we need to change. This is how the 1's complement of the binary system will work. Let's take another example. Let's take minus 5 here. For this, we already know the basic representation of this 5. Okay. Let's consider 2 power 0, 2 power 1, 2 power 2 and 2 power 3 here. Here we are going to get 0, 1, 0, 1 because the value of 5 is 0, 1, 0, 1. For the 2's complement, we need to flip the numbers from 0 to 1 or 1 to 0 and we need to add 1 at the end. Let's change these numbers. Here 0 we are going to get 1, here 1 we are going to get 0, here 0 we are going to 1, here 1 we are going to get 0. And what's the rule? The rule is we need to add 1 at the end. Okay. So what we are going to get here? We are going to get 1, 0, 1, 1. Now let's move with the other example by subtracting one number with the other number. Here we are subtracting 2 from 3. Let us consider the 4-bit here. 4-bit. So for that 4-bit we are going to get like 8, 4, 2, 1. Okay. Let us write the value for 3 now. What's the value for 3? That is 0, 0, 1, 1, right? 0, 0, 1, 1. For 2, for the minus 2, let's write the value for 2 first. What's the value for 2? That is 0, 0, 1, 0. 0, 0, 1, 0. And for minus 2, we are going to flip the numbers from 0 to 1 and 1 to 0. Here we have 0, just flip it to 1. Means we need to flip to its opposite value. Here we have 0, flip to 1. Here we have 1, flip to it 0. Here we have 0, flip to it to 1. This will be our minus 2 and this is the 3. We need to add these two numbers to get the final value for 3 minus 2. Okay, let us go write the first value, that is 3, 0, 0, 1, 1. Second one is minus 2, 1, 1, 0, 1. Just add these two numbers. By adding 1 and 1, we are going to get 0 here and 1 has carry. 1 plus 1, same, 0 will be here, 1 is carry. Same 0, 1 carry, 0, 1 carry. Here 1 is left out as carry. Means the value, final value we are going to get, that will be the positive number. So we need to add this carry at the beginning of the number. So what we are going to get by adding this carry at the beginning, we are going to get like 0, 0, 0, 1. This will be our final value for 3 minus 2 by using 1's complement. Let us consider the fourth example, like previously we considered 3 minus 2. Let us consider like minus 3 plus 2. Okay. Let us consider 4-bit here also. 2 power 2 and 2 power 3. For 2 power 0, 1, this will be 2, 4, 8. For 2, we are going to get like 0, 0, 1, 0, 0, 0, 1, 0. And for 3, we are going to get like 0, 0, 1, 1, 0, 0, 1, 1. Let us write for the minus 3 here. Here we are performing the 1's complement. For the 1's complement, we just need to flip the numbers from 0 to 1 and 1 to 0. Here we have 0, 1, it will be shifted to 1. And here we have 0, we need to flip to 1. For both the ones, we need to flip to 0.